Okay, we're moving into pre-calculus. Okay, so pre-calculus is a study of functions. We'll see when we're done today what functions are. At least these things are functions. We'll see in what way these things are functions. And this camera zoomed back on me again. I don't know what reality it lives in, but there it is. Anyhow, pre-calculus functions. These are three functions. Now, all we're going to do with these right now is we're going to fill in tables. Okay, we've got values of x, -2, -1, -1/2, 0, 1, 2 here. And we got y equals x squared. Meaning that in this column, we're going to take whatever x is and we're going to square it. And that's going to be our value of y. And then we're going to construct a graph of y versus x, which is pretty easy to do. You can teach a third grader to do that, but you can't teach a third grader to think about what these functions mean. Okay. And a lot of times you can't teach a college student what how these things work. We're going to try to give you some head start on this. So when you start into your pre-calculus course, you'll have some idea what the terrain is. And not just get blown away at the very beginning, which is pretty common. We want to avoid that. Okay, so for if x is -2, then we got to find x squared. So we write -2 squared equals, and then we do the arithmetic. Okay, just like here, if you got -1/2, well, x is squared. -1/2 squared is what? Okay. Over here, 1 over x. So if x is -2, you're doing 1 over -2. Over here, if x is -2, you're doing 2 raised to the x power. So the -2 is going to be your exponent with your base of 2. Okay. So then similar. So we ask everybody to fill in tables and apply the rules that we've been using pretty much throughout the course, okay? Rules of exponents and rules for fractions is what we really need to evaluate these. And we're not using calculators, okay? Calculator is a way of getting the answer without knowing what anything means. Okay, it doesn't give you any information. Now, sometimes you need a calculator. Like you'll notice I didn't put 1/2 in here where I had 1/2 here and here, okay? The only way you're going to get 2 to the 1/2 power, which is the square root of 2, if you remember about fractional exponents, you're never going to get it. It's an irrational number. It keeps going and it's totally unpredictable. You just got to calculate it digit by digit, and you don't have any idea how that's done. Okay, you have to, that's something calculus students right now, first year calculus students will learn to do, right around this point in the semester. And of course, it goes on forever, so you're never done. So we're not going to put 1/2 in here because you can't calculate it. Okay, all these other numbers you can calculate, and we're going to base our understanding of functions on numbers that we can calculate. Okay, now at this point, I just turn people loose. I'm going to take a look at what they do. If you're watching this in video, as half the class is going to need to do because they're not here today. Long weekend, people, I don't know. And some confusion over the assignments. One person mentioned the assignments don't appear to be in order. I say you got to look at the calendar. Okay. But it looks like people missed some assignments. Don't worry too much about those assignments right now. This is what you need to be focusing on. Okay. What's done is done. People have done pretty well with it. We'll see if we've done well enough. But right now, we're just going to go back to the real basics, just doing arithmetic with numbers, okay? And we're going to pretty quickly develop that into the whole idea of functions. Okay, now there are really only 2 rules we need to do this stuff, apart from the rule that like if you square a negative number, you get a positive because a negative times a negative is positive. And I think everybody understands that, even though people tend to overlook it. You get a little confused about how to do the arithmetic with simple numbers. It's not totally simple, but our prerequisite courses really should do a better job, should take calculators out of people's hands and make sure they can do these things. That's my take on what we need to do. But anyhow, it is what it is, so let's go with it. Okay, so -2 squared is what? Well, I'm going to do some of the arithmetic over here on another board. Okay, so what's -2 squared? That means -2 times -2. There's no fancy rule. It's -2 times -2. Then if you multiply -2 times -2, you get 4. Okay. Now, normally I would write that out here. I'd write -2 times, well, I can actually do this. -2, got to do it kind of small, but you know what I'm writing. And you get 4. I think everybody got that. Okay. But there's a strong tendency to put a -4 there. You see a negative, it stays in your head. And you see that happen with me when I write things down carelessly. Okay. I know better, but sometimes I'll write something down without thinking. It's real easy to do that. Okay. And then -1 squared. It's 1, right? What's 1/2 squared? -1/2 squared. Well, I'm going to leave myself a little more room here. And I'll actually go ahead and write it in. Because it'll be easy enough to see on the video if I just write it clearly, which is always a challenge. -1/2 times -1/2, right? Now, if you do first of all, you're multiplying 2 negative numbers, so you're going to get a positive. Then you multiply the numerators. Now, that's a lot to write out, but it doesn't take long. And I don't have room to write it out, but that's why we come out with 1/4. Okay. Now, what about 0 squared? Well, nothing times nothing is nothing. Okay. Nothing from nothing ain't nothing. Nothing from nothing leaves nothing. Song. Okay. Never particularly liked the song, it was a little bit catchy. Okay, so then 1 squared, of course, is 1, and 2 squared is 2. We don't really need to write out a whole lot. Okay. Okay, so let's go to this one, because this one only involves negative exponents. This one involves fractions, and that throws people for some reason. Okay, so what's 2 to the -2? Didn't leave myself a lot of room there. I was thinking about that when I wrote it out, but I wanted to leave plenty of room over here. Okay, 2 to the -2 is 1/2 squared. The basic rule. Now let's just write down a couple of basic rules over here so we keep them in mind. Okay. First, a rule of exponents. Hey, get it. Oh man, I missed it. A to the -b is 1/a to the b, right? And also, with fractions, just to write this down, a over b divided by c over d is a over b times d over c. In other words, when you divide by a fraction, you multiply by the reciprocal. We're going to need that over here. We don't need it here. We only need this one. Getting both done. Okay, so anyhow, so 2 to the negative 2 is 1 over 2 squared equals 1 over 4. Okay. Now I'll write that down here. 2 to the negative 1 is 1 over 2 to the 1, which is 1/2. What's 2 to the 0? Any number to the 0 power is 1. There was a little confusion. Somebody said, what's 0 times 0? Isn't that 1? Okay, no, but any number raised to the 0 power has to be 1. And there's a reason for that I'm going to mention. Why is 2 to the 0 equal to 1? Well, this isn't really an explanation because it's a convention, but it's consistent with the other rules of exponents. Like, what's 2 to the negative 3 multiplied by 2 to the 3? Well, in one case, that would be 1 over 2 to the 3rd times 2 to the 3rd. And of course, that could be 2 to the 3rd over 1. So that's 2 to the 3rd divided by 2 to the 3rd, which has to be 1, right? If you apply the rules for exponents, 2 to the negative 3 times 2 to the 3 equals 2 to the negative 3 plus 3. You add the exponents. And there's a reason you have an exponent. You got 2 squared times 2 cubed. That means you got a couple of 2's here, and then you got 3 2's here. That's 5. Okay? Remember how we wrote that out? You got to remember that. Otherwise, you will get confused at some point about the rules for exponents. Okay, well, anyhow, there it is. And negative 3 plus 3 is 0. Well, this equals this, so this has to equal this. So 2 to the 0 better be 1. Now, real common error, when we graph this, you'll see this, this messes up the graph terribly if you think that's 0. Okay, your graph just doesn't make any sense anymore. Okay, so 2 to the 0 is 1. And you're going to see about the graphs. Okay, and 2 to the 1. Well, any number to the 1 power is just itself. And 2 squared means 2 times 2, which is 4. So I won't even bother writing that. I could have wrote it out. Oh, I didn't ever write it out. I wrote it out for negative 2. It's easier for 2. Okay, so now we got these values. Okay, over here. Now, 1 over negative 2 is what? Well, that's, or conventionally written as negative 1/2. Okay. And 2 to the negative 1 is 1 over negative 1, which is negative 1. Okay. Now, what about 2 to the negative 1/2? I'm going to ask you to write this out. Write out the details of the calculation. Okay. Did I say that right? In any case, 1 over negative 1/2. I'm going to apply the rules of exponents to calculate 1 over negative 1/2. Okay, now we often run into a hang up here. What's 1 over negative 1/2? Okay. Well, the rule for dividing by a fraction is you multiply by the reciprocal. Now the numerator is here is a over b, but that's just like 1 over 1, right? Okay, so we could adapt this rule. So let's write it out. 1 over negative 1/2 is we could write the numerator as a fraction, just to put it in this form. 1 is the same as 1 divided by 1. And this is then -1/2, which is then 1/1 times -2/1. Okay, so we just take the denominator and you flip it. And that then is numerator times numerator is 1 times -2/1 times 1, which is -2. Yeah, I think maybe I'm off the edge of the board there. Let's see how much space I've got. You know, I'm not sure I was even on the board with this whole explanation. Might have to go back and look at it. But anyhow, this is going to give you, if you wish, 1/1, that's is 1 times -2/1, which is -2. Okay. Now, again, I'm not sure. We had this, which is, I did a lot of these calculations over there, but here's the whole table, which I think wasn't all visible when I did it. Okay. This one's pretty straightforward. These two are the ones that throw you curves. Over here, all you got to do is be careful of, first of all, know what it means to square a number. So that -2 squared is -2 times -2, and that gives you 4, because you know the two negatives multiplied together give you a positive, and so forth. And then with the fractions, of course, you deal with a fraction. The square of -1/2 is -1/2 times -1/2. Multiply the numerators, you get 1. Multiply the denominators, you get 4. Negative times negative gives you a positive. Of course, I wrote that down over here. That's where all that came from. Okay, so I do apologize if that wasn't visible. Okay, now, what about 0? What do you do with 0? Let's discuss that for a minute. Because there's some important things about 1/0 that we got to be somewhat aware of. Before we do 1/0, it occurs maybe better do 1/1/2. We multiply. We're dividing by 1/2, so we multiply by the reciprocal. And that gives us 2. And what's the actual, that's how you calculate, what's the actual meaning of dividing 1 by 1/2? Well, how many $half does it take to make $1? Show me with your finger. Anybody ever seen a $half? Because there are not a lot of them in circulation.
Not everything.
Yeah, it used to be all over the place. But, okay, so how many $half does it take to make $1? 2, right? Okay. How many quarters does it take to make $1? So what's 1 divided by 1/4? A quarter's 1/4 of $1. That's what we call it, a quarter, right? It takes 4. Okay. How many dimes? A dime is 1/10 of $1. How many dimes does it take to make $1? It takes 10. How many nickels does it make to take $1? Yeah, how many nickels does it take to make $1? Okay. Yeah, you gotta use your toes or flash your fingers out there twice or something. But obviously 20. A nickel is 1/20 of $1. It takes 20 nickels to make $1. Now, I won't ask you to gesture, but you know how many pennies it takes to make $1, right? Okay. 1,000? No, it takes 100 pennies to make $1. Okay, penny is 1/100 of $1. If you divide 1 by 1/100, you get 100. Okay. If you divide 1 by 1/20, you get 20. Okay, so I can write that out. Won't write all of them out. 4/4 make $1. So 1 divided by 1/4, that's like $1 divided by the value of $1 divided by the value of a quarter is 4. That's what it means to divide by a fraction. And of course, this is what you get if you multiply by the reciprocal, right? Okay. And the original example with $half, if anybody's ever seen one, okay, and many of you have. Most, I think most people have. It's a kind of mysterious thing, seems that they're rare. Not really all that rare. You can go to the bank and get them, I think. Okay. They don't work in vending machines very well, which is probably why they are not being used much anymore. People decided that quarters was enough. Okay. So this is like you divide $1 by $half, which is how many of these does it take to make this? That's what division means. Okay. So if you divide $1 by $1/4 of $1, you get 4. It takes 4/4 to make $1. And then we went on, okay, it takes 10 dimes to make $1 because a dime is 1/10 of $1, right? Now you're dividing 1 by 1/10, that gives you 10. Nickels, 1 divided by 1/20, because it takes 20 nickels to make $1. Little attention to detail here. It's obvious. If you divide $1 into nickels, you're going to need 20 of them, right? The value of $1 divided by the value of a nickel is 20, because it takes 20 nickels to make $1. And pennies, okay, 1 divided by 100 equals 100. What happens is these numbers, 1/4, 1/10, 1/20, 1/100, these numbers are approaching 0. They're getting smaller and smaller, right? If you divide 1 by numbers that get smaller and smaller, what happens to the result? It gets bigger and bigger because it takes more and more tiny things to make 1, okay? Or whatever number you're dividing. If you keep dividing by numbers that approach 0, your result is going to get bigger and bigger, okay? Because it's going to take more and more tiny things to make whatever it is you're dividing by. And no matter how small the number, you're dividing by the tiny number. Eventually, the tiny number is going to be a lot smaller than whatever your small number is, because it isn't going to change, right? So if you're like dividing 1/1,000,000th by tiny numbers, okay? Well, by the time you get down to dividing it by 1/1,000,000,000th, it takes 1,000 of them. Okay, so whatever your number is, well, maybe I'm saying more than really needed right now. But those are ideas you kind of want to ponder. And what we're really talking about then is infinities. And my grandson, 8 years old, was in here. I think I mentioned it. I think I had the stuff on the table Christmas time. But it probably wasn't here by the time this class started. But ask me, what's infinity plus infinity? They're thinking about numbers. Okay, so I can actually explain that to an 8-year-old. It's hard to explain to a college student, but it's easy to understand to an 8-year-old because they're thinking about it. Okay, college students say, "Why is that?" You know, okay, because you've been ruined by the education system. We're trying to save you. Okay, now you're really not ruined. There's some habits of thought that you want to develop here. Okay. Okay, the reason this is important is because of what happens to this graph and what happens to the graphs of rational functions, which is something that you're going to love when you get to it pre-calculus. Okay, so this is really important from your perspective. Now you know how to simplify rational functions and stuff. At least you're acquainted with it. You might not be expert at it, but you know, you have time to develop that. Okay, so anyhow, this is what you have. Okay. So if you divide 1 by 0, Well, as your numbers approach 0, you get bigger and bigger results, right? When they get to 0, what's that give you? It doesn't give you a number. Okay, because the number you get is the number, as x gets closer and closer to 0, the result that you get when you divide 1 by that number gets bigger and bigger without any limit to how big. So there's no number that represents 1 divided by 0. Okay? So you can say, well, it's infinity, but infinity isn't a number. So this is it's not a real number. And we say it's undefined. So we're not going to attempt to put that on our graph. It approaches infinity. Okay, and then of course we get 1 over 1, which is 1, and 1 over 2, which is just what it is. Okay. Well, those are the numbers on our 3 tables. So now I'm going to construct graphs. I'm going to construct graphs of these 3 functions. Okay. Now let's make sure I've got this board okay. Now I can write this table down really quickly, but I don't want to memorize these numbers. Okay. I want to always calculate them because there are only 7 of them, and one of them in this case is undefined, right? So we have -2, -1, -1/2. I'm going to put 0 in here because just out of habit, we're going to do that. Okay. And I'm going to remind myself that 1 divided by 0 is undefined for all the reasons that I talked about. Okay. Then this is -1/2. This is -1. This is -2. And this is 2, and this is 1, and this is 1/2. And you should be able to verify those calculations in your head as you're writing them down. Because if you don't understand these numbers, you don't understand these functions. And these functions are the basis for almost all of pre-calculus and calculus. Now, there are about 5 of them that are supremely important, and then a few more, and you're going to see those in your assignments, okay? We just have to be able to do the arithmetic. Okay, so that's this function. Okay, well, I'm going to draw this graph. Now, I noticed that my numbers get as low as -2 and as high as 2, right? Okay, so I'm going to have -2 down here, and I'm going to have 2 up here. Okay, and this is going to be my y-axis. Okay, now let's be sure. I'm assuming you've seen graphs, but if you haven't, I'm going to explain as we go. Okay, and then 0 would go here, and of course, this is where our x-axis is. So I'm going to label this as the x-axis. So my x values are measured along this line, and my y values are measured along this line. And notice that my x values go from -2 to 2 as well. So I can put -2 here, and I can put 2 here. Okay. Now I'm also going to need -1 and 1, right? Well, it's easy to get -1 and 1 on these graphs. 1 is going to be halfway between here and here. So you just take that and you divide it in 2, and right here is 1. And actually, my 1 was, yeah, it's about right. Okay, and -1 is going to be halfway here. And then similarly down here, you're going to have -1 here, and you're going to have 1 here. Okay. Then you're going to want 1/2 and negative 1/2. Now, you want to be careful how you construct this thing, because there's something I see a lot, and I'll tell you in a minute, but I'm going to show you how to do it right, and then I'll show you how people often do it wrong, okay? You don't want to do it wrong. You want to be able to hand construct these graphs. Graphing calculator, I don't even use them in my pre-calculus course, okay? Some people do. And there are ways they can be used that are good, but calculators have been misused so badly, which results in people not knowing the rules for exponents and stuff and fractions, okay? And not understanding these functions. We want to understand these functions. It's the number one thing you want to do to understand what's going on in pre-calculus. Okay, so here we have our x values. We're trying to find where x equals, let's say, 1/2. Now, where's that going to be? Well, that's going to be halfway between 0 and 1, isn't it? Okay, so right here is 1/2. And here is negative 1/2, right? And then we can do the same thing for our y values. Here's 1/2. Down here is negative 1/2, but things are getting too busy in here. I can't really label them. Okay, so we're just going to understand that's 1/2. Now notice that the distance between these 2 points and these 2 points is only half the distance between these 2 points, because when we construct it by starting with -2 and 2 and then dividing things in half, that's the way it turns out. Now, what I see a lot is I see graphs that look like this. I'll just do the first quadrant to get the idea. Here's 1/2. Here's 1. Here's 2, equally spaced. What's wrong with that? Well, this is how big 1 is, but then this is how big 1 is. Because the distance from 1 to 2 is the same as the distance from 0 to 1, right? But it isn't if you draw the graph like this. And that's going to distort the picture of the function that you're trying to construct. And we want an accurate depiction for reasons that you'll not fully appreciate until you start modeling the real world with these functions, okay? And we're not going to be able to do much of that, but I'll kind of allude to it to give you a little bit of the picture. Okay, well, now that we've got that, we start graphing points. Again, this is something you should be familiar with, but again, you know, in some algebra classes and stuff, the only way you get a graph is punch it into your graphing calculator. You never understand what was done. Okay, now, there are a lot of good reasons to be able to interpret a graph, and your graphing calculator will give you a nice graph. And if it's a complicated function, you're probably going to need the graphing calculator. I'll need the graphing calculator for some functions, although I can do quite a bit with analysis of functions, okay? Way beyond what you'd even expect. But that's still, I've got my limits just like you've got yours, okay? Okay, so let's just take some of these points. -2, -1/2. When x is -2, that's here, right? So we can even draw this, okay, here. Here's where x equals -2. Every point on this vertical line has x coordinate -2, doesn't it? Okay, because every point on this line lies above or below -2 on the x-axis. And y is -1/2. Well, it's kind of unfortunate in the way I labeled this thing because I wasn't fully seeing it. So this is going to kind of interfere with my -2, but I'm going to have a point here. Okay, so when x is -2, y is -1/2. And I didn't label the -1/2, but we understand that this is a line where y equals -1/2. And where the line for x equals 2 intersects the horizontal line for y equals -1/2 is our point. Now, do we understand that? Is that something that you've seen before? Okay. So let's just ask, where's the point -1/2, -2? So see if you can sketch this graph. See if you can construct it the way I did and graph the point -1/2, -2. Well, I love it when people exceed expectations. Okay, although I wouldn't necessarily predicted you wouldn't, but I would think that depending on your background, you might or might not be pretty good at this, but everybody's real good at it. And I think everybody just pretty much completed the whole stupid graph. Okay, so I think I can move through this a little faster, but you know, only half the class isn't here, so I want to still do a good explanation for them. So -1/2, -2 means that x is -1/2. Well, that occurs here. And y equals -2. That occurs here, so the point is here, right? Now I'm going to put the rest of the points down a little more quickly. When x is -1, y should be -1. If you're watching this, you should plot that point before you see me do it. And you should try to plot all the points before I do them, because that's exactly what we did in class. Okay, so you got -1 and you got -1. So right there are 3 points. Okay, but we're not going to connect the points just now. We're just going to get the points, but I'm going to tell you what we do when we connect. The one thing you don't do is you don't do a straight line from here to here and a straight line from here to here. I see that. And, you know, that just makes me wonder what's going on out there. But it might just be that teachers are desperate for their students to do something because their students aren't doing anything. Okay, so not blaming it on the teachers, but the whole education system screwed up. It does some things well. And apparently does this well because everybody just slopped this thing down almost instantly. Okay, so whatever you had, I'm pleased you had it. Okay, so one thing that I'm going to say in advance, though, and you don't necessarily have to understand this right now because we'll repeat it, but okay, you're going to have a curve here. Okay, and then you ask yourself, what's the rest of the curve look like? Okay. So we don't know, so we're going to stop it. We're going to start it here. We're going to stop it here. We're not going to go any further. And another thing we're not going to do, well, you see in a minute. Okay, if we go to 1/2, 2, well, that's up here. I'm not going to label everything anymore. There's a point. And 1, 1, well, okay, there's 1, there's 1. And then 2, 1/2. Here's 1/2. Here's 2. Those are our points. For now, I said we weren't going to connect the points, but I'm going to make an important point here. You notice that 0 is undefined, right? That this function is undefined when x equals 0. 0 is not undefined. Function is undefined. We're not going to try to connect this point to this point. Okay? Because what happens if we connect this point to this point? We go through the y-axis, which is where x equals 0. And wherever we go through it, then we're saying, well, that's 1/0. We can't do that. There's no such thing as 1/0. So we can't go through the y-axis. We don't try to connect this point to this point. That splits this graph into 2 halves. Okay, so if we are connecting, we're not going to extrapolate until we've had a chance to think a little more. We're going to get this. Now, your assignment probably will extrapolate the thing. I don't think it's a good idea, but that's what open math gives me. And I don't have time to rewrite it. Okay? At least not right now. Okay, so the graph's going to look like this. Now, because you're going to see it in your open math assignment, the graph keeps getting closer and closer to the x-axis. So you have what you call an asymptote at the x-axis here, and an asymptote on this side, and you have an asymptote to the y-axis up here, and an asymptote to the y-axis down here. The asymptote comes about because of what I was talking about when you divide by 0, a number close to 0. And the asymptotes this way come about because of what happens when you divide by big numbers, which gives you small results. We don't need to worry about that right now. We're not going to worry about that in this course. We'll worry about it quite a bit in pre-calculus, whichever pre-calculus course you take. Okay, so we've got this. There it is, right? Now, how about the graph of, okay, so this, let me put just a little bit of labeling in this graph. This is y equals 1 over x and we call this our basic reciprocal function. Okay. Now in my class, I said basic reciprocal function, just the points. And then I have an extended reciprocal function, which is what I've drawn when I drew the curve through the points. Then the complete is what happens when we get all the asymptotes. But that's not something we worry about right now. And you might not have to worry about it unless you're in my course. Let's go to the 2 to the x graph. Again, I don't put 1/2 in here because you can't calculate it. Your calculator can't calculate it. I mean, it'll give you 10 or 12 decimal points, okay? 10 or 12 numbers after the decimal point, but that's not an exact result. And I want to confine ourselves to exact results that we understand in terms of the rules of arithmetic, not in terms of what a calculator puts out. Because that's all you really need to understand these basic graphs. Okay, so if you recall, our numbers are 1/4, 1/2, 1, 2, and 4. And that's pretty easy to graph. So I'm going to put -2 here and 2 here. Because our x values go from -2 to 2. We call the interval from -2 to 2 the domain. It's a set of all possible x values. And we'll say more about that on Wednesday. Now we label our axis by subdividing. And then we label our y-axis. Now our y values go from pretty close to 0, like at 1/4, all the way up to 4. So we don't need negative y values, and I anticipated that by not putting a lot of negative y-axis here. Because when I look at these numbers, I see there are no negatives. So there's no point in having a lot of negatives here, unless we're going to flip the graph over, which we might well want to do. So we can see that graph I just showed you on the lab interface. Okay, but anyhow, here's 4. Now, what are we going to do? We're going to divide this interval in half. Anytime you can, you divide intervals in half, because that's easy to do and it's easy to get it pretty accurate, even though I kind of missed something like that. So if we divide this interval in half, we get 2. Divide this interval in half, we get 1. Divide that in half, and we get 1/2. And divide that in half, and we get 1/4. So you see, I've gone all the way down, subdividing, all the way down to 1/2 and 1/4, because those numbers are on our table. Those are y values. And then up here, we've got 3. And I notice that nobody's paying any attention to me, which is great, because you're just sitting there doing it yourself. Okay. Now I'm going to continue with the explanation for people that aren't here, but you know, it's exactly what I want to see. I'm irrelevant and I love it. Okay. Now I'll be there if you need me, and when you do, because you will. But I'm glad everybody's doing well. Okay, so we got -2, 1/4. Well, that's going to be here. -1, 1/2 is going to be here. 0, 1 is going to be here. 1, 2 is going to be here. And 2, 4 is going to be here. I didn't need -1/2 and +1/2, but I've got them on here because we can use this graph to at least estimate what these are, what the values of the functions are. Okay, so if I draw the curve, it's going to look like this. Now, this curve is good for a lot of things. For example, the shape of this curve tells you if you put money in the bank at a certain interest rate, your money's going to change according to this curve. Okay? This curve is pretty universal. It happens all the time. If you have an invasive species, it tends to take over like this. Okay? If you got lilies growing on a pond and start with just a couple of lilies, they just grow like this. You got a fish tank and have a bunch of little guppies, a few little guppies, you're going to have a guppy population that does this, at least until they start filling the tank, and then things level off. Okay? It's a very important curve, very important curve for business, for science, for almost anything. And I noticed that I could estimate 2 to the 1/2 power. All I have to do is come up here, then come over here. And that number is a little closer to 1 than it is to 2. We're going to say it's about 1.4. Well, 2 to the 1/2 is the square root of 2. If you square 1.4, you get 1.96. Okay, so the graph confirms it, and it tells you about what 2 to the -1/2 would be. It's between 1/2 and 1, somewhat closer to 1/2, but not so close that you call it 0.6, it's about 0.7. If you draw this graph carefully, you're probably going to get those estimates, and they're really pretty close. Okay? Now, the reason why your calculator does it is they have a bunch of really, really good graphs drawn in your calculator, and they do this with those graphs. And if you believe that, you're too gullible. Okay. This is called your basic exponential function. And there's another one that's even more basic. The basic, the y equals e to the x, where e is the Euler number and stuff like that, between 2 and 3. I'm not going to talk about that right now. When you get into calculus, you would begin to appreciate what's so neat about that function. Okay? But anyhow, there it is. Now, I'm just going to draw the shape of the graph because it's the easiest one, and I saved that for last. And I'm glad now. I was a little dubious about whether I wanted to do that, but everybody did so well with this. Okay. The x squared function. I'm just going to use this little bit of space down here. Okay, there are the numbers. We know where the numbers came from. We've worked it out. This one again gives us only positive numbers. So let's say 2's here. -2, so they're not going to label the points, but you understand, I'm getting 1 and 1/2 here. I'll do the 1. And then I've got to have 4 up here, so it's going to be labeled, the scale is going to be just like the graph of the basic exponential function, but the shape's going to be very different because -2 gives us a point here. -1 gives us a point here. -1/2 gives us a point way down here. And 0 gives us this point. And then we get 1/2, 1/4, and 1, 1, and 2, 4. I didn't give you time to do that, but if you can do these, you could certainly do this. Okay? And this graph has a shape much like this. Okay, and this is your basic squaring function, y equals x squared. Called a parabola. Spelled just like it sounds. And it's extremely important. Okay. Yeah. Yeah, if you see the number without knowing how it's pronounced, there are all kinds of ways it could be pronounced. You have a couple more functions that you'll see in your open math assignment, but it's pretty straightforward. If you take this function and reflect all the points around the x-axis, so this point reflects down to here, and this point reflects down to here, and this point reflects down to here, and this point down to here, and this point down to here. This function would be negative or 2 to the x, because all your y values go negative, okay? They have the same size. If you reflect this thing around the y-axis, so you take this point and reflect it over here, and this point reflected over here, and this point reflected over here, well, here, and so forth. Okay, it should cross this one on the axis, but I kind of missed it. This is y equals negative of 2 to the negative x. If you pick this graph up and move it up here, and extend it a little bit, not the bigger x values. Okay. Get this, and this is almost a perfect exponential curve, but you reflected the thing And so if we lift this thing up, then it could end up looking like this, which is a graph we saw on the device for the charging of capacitor, turns out. Not important to understand that, but some of you have some background in that sort of thing, so I mentioned it. Yeah, we got a comment here. Okay, we don't have time to discuss this at any length, but somebody asked you, there are 5 functions. Well, your book actually gives you about 7, you'll see them. And if you understand these, you'll understand those. Like the others are and I think your materials might call these toolkit functions or sometimes parent functions, okay? So when you see toolkit or parent or basic, it's all the same. Just different authors use different words for them, and they're all good words. Okay, not as good as the one I use, but they're all good. Okay, so the basic functions are the x cubed function. And certainly you can make a table for x cubed. Just be careful about your sign. The reciprocal square function, 1 over x squared. And that makes up, with these 3, the 5 that I regard as the most basic. Okay, you also have the absolute value of function. And you even have the step function, which I'm not going to write down because of notational confusion. Okay. And then your book says the square root function, and I say that's not a good thing to talk about right now, because the square root function is the inverse of the squaring function. And you get the inverse function by switching the 2 columns. So this graph turns over on its side and gets inverted in a strange way that we won't talk about right now. And the logarithmic function, okay, which is just the inverse of this one, which just puts it down here like this, okay? Kind of like this. It's just kind of a reflection of this through the y equals x line, okay? And you don't necessarily know that. Now you mentioned the bell curve. It's like y equals 2 to the negative x squared. Okay, but it's really 1 over the square root of 2 pi times e. E is a number, it's about 2.7. Okay, now you could easily do a 3 to the x function, right? Yeah, instead of -2, you get at -2, you get 1 over 3 squared, which is 1/9. Down here you get 9. So have the same basic shape, but it'd be steeper. Okay. And the e to the x function has a graph that'd be between the 2 to the x and the 3 to the x, same shape. Okay. Just with different labels. Okay, this would be e to the negative, and usually you use z. E to the negative z squared over 2. So what you're doing is you're combining a basic function like the 2 to the x function, except it's an e to the x, okay, with the squaring function. And in this case, with a squaring function divided by 2, but with a negative, okay, the negative of the squaring function. And that gives you your bell curve. And that's kind of neat, kind of worth knowing.